Hello everyone, I'm your host as always, Mr. Lindley. Ball in the cup. What nightmares are made of? Some students wondering if it'll ever go away. Others arguing it is one of the most important things we've done this entire school year. For more, we head into the classroom.
Dun 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 dun. Spend your time waiting for this roll, for the points that could make your grade okay. There's always a reason to feel not sure enough. Did you measure all the right things? Did you calculate properly? Where do we put this cup? Does air resistance matter? Oh no, our time's up. Let's trust in physics tonight. In the cup you will roll on down that ramp. In the cup you will roll, at least in my dreams. Doom, 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 doom.
Yeah, it kept coming up again and again and again. I wonder if it's important to us. Who knows? We'll find out. Ball in the cup. Is it just a heart-wrenching in-class experience for students? Is it the ultimate way to dip your chicken nuggets in that sweet sauce? It's all of these. Let's talk ball in the cup. Now, to discuss this, let's talk about what ball in the cup is fundamentally, and then the many, many ways we could do it. Now, the basic generic setup for ball in the cup is you have some sort of table, you have some sort of ground, and you're going to get an object that leaves the table. Okay, it's going to leave the table like this, and it's going to fall, and you want to know where, in fact, do we place the cup such that it goes in there. Now, the question becomes, how does it begin to move? We'll get there. We'll learn about just this piece. So if we're just trying to have it land in a cup like this. Now, one of the things we need to know certainly is how fast it was going, and we probably call that that's like a vox, right? Like a horizontal velocity. And we're trying to figure out, where basically this is what we normally define as R, range. Could be a D for distance as well, but it's where am I placing that cup so that my object is going to land into it. So let's sort of work this out a little bit. This first step here would be making a chat, a double-sided chat. Making a double-sided chat. It's a double-sided chat. So if I'm setting this up, I'm going to make my life easy and call down positive for this example. So this would be little g. Void would be 0 because it's only moving horizontally when it's launched. The horizontal acceleration will be 0. And now what I need to know is there's going to be some height of the table, right? But there also would be some height of the cup most likely given. Now we want ball in the cup, not ball hit the cup, not ball bounce out of the cup. That'd be okay actually. Not ball hit the rim, right? We want it in the cup. So if we think about it, the delta y we actually want it to go from where it is to the top edge of the cup. That'll ensure that it goes in. So delta y here would actually be the height of the table minus the height of the cup. If you were just having it hit a spot on the floor, it would just be the height of the table. Now, in order to try to solve for this, so if we look what we're trying to solve for, we're trying to get that box in my chat. I'm going to have box. Again, we'll talk about that in a moment, but I'm going to have that. So if I try to think about, how I would typically start these problems, the horizontal side of this is 2 and lose, so that's not going to work. But, oh man, I thought that was the highlighter. That's a 1, a 2, a 3. a 3. So the first thing in my pilon is I'm going to try to find time. And once I find time, I can bring that over. And then once I have time, now you can see I have 1, a 2, and 3, and I should be able to solve for delta x. This part of ball in the cup is always the same. It doesn't matter how it begins. It is always identical to this. Now let's talk about a couple ways it could start. Right? The very simple example from way back was you were given here, you were given a distance, and you were given a time that it took to take this, and you would just divide those two to figure out what that Vox was. Right? That was sort of the first way that we ever did this. But that's kind of lame, and I don't see that happening again. But a more common way is, what if I had a ramp? Now, if I have a ramp, there's a lot of things that would matter here, because if you can see, I can basically turn this into a 3-phase problem. Now, the third phase is not going to change. So it's going to move down this ramp. Now, on the ramp, maybe there's an entire video on ramps you should go watch. We could use dynamics, forces and kinematics, to figure out how fast it's moving at the end of that. I mean, I think advise energy, because no matter what, we're gonna start with UG, and then when it gets to the bottom here, it's either gonna be just kinetic or it's gonna be kinetic plus heat, either way, right? And then what would also matter is on this flat part here, is on the flat part, is this frictioned or not? Because if it's friction on that flat part, it's going to lose some speed there as well. So, those are some things to watch out for, because it'd be UG to K plus Q, right? And then it would slow down even further from there. So it'd be like K, and then even more heat at the end. But a lot of times, we would have friction on one of the parts, not necessarily all of the parts. But for us, the big thing about ball in the cup is the end piece is always identical, because there might have been another example where there was a chicken nugget spinning on a string. What matters is, for you and for us in these problems, is we need to get Vox. So do the problem almost as like two separate problems. The second piece is ball in the cup, which is laid out here. The first part is do the problem to figure out how fast the object's moving. Is it a ramp? Right? Is it something that's spinning and then a string breaks? Right? Is it a spring? Man. Is it a spring that's all squished that's going to actually like launch the ball like pinball? And that would be energy. So there's lots of different ways we do it. Is it that there's a table and the ball is just chilling and there's a block that's going to come in and have a collision, which I believe was a problem called bullet block or something similar to that. So there's a lot of different starts to the problem, but in the end, they are always the same. Now, I hope that helps with a little ball in the cup action. Hit that like and subscribe. And until next time, happy reviewing.